So I want to talk about the maybe monad, and this monad got kind of internalized in C#6 with the question mark dot operator, but in actual fact the maybe monad is only part of something bigger, something more complicated that you yourself can build and thereby get additional benefits. So this is what this particular demo is all about. Okay, so let me show you first of all the kind of motivating example of the kind of problems that the maybe monad and indeed the question mark dot operator try to solve. So let's build a maybe monad demo. So I'll just stick a main in here. Now let's suppose that we have a class called person. So I'll have person here, and person might have public address. Okay, that's wrong kind of completion. Address like so. It might be a property, and then of course this would be an additional class somewhere, and inside address you might have additional nullable things, like for example you might have a postcode. So now the question is, well, let's suppose we have some piece of API which tries to get the postcode out of a person. So you have some sort of method with an M, and this method takes a person, and then you try to typically get the postcode, assuming that none of the constituent parts are null. So before C#6, the way you would write it is something like the following. You would say string postcode equals null, and then you would then check if p is not equal to null and p dot address is not equal to null. And actually, let's change it from null to unknown. That would be the default value. So the postcode is unknown by default unless you jump through all the hoops. You say p dot address dot postcode not equal to null, and that's where you can assign it. That's where you say postcode equals p dot address dot postcode. Now this time, the time when we did this kind of thing is now gone. In C#6 you no longer write this kind of code, because you can now write something like postcode equals p question mark dot address question mark dot postcode. So this is what you can do right now, and it works just fine. Unfortunately, in the real world, in between those different null checks, in between this check and that check, you might also have additional code, in which case your null operator, your question mark dot operator, is completely useless. So let me show you the kind of stuff you typically encounter. So just as an example, so you would have string postcode, and then you would say something like, oh, okay, if p is not equal to null, then I want to check some additional conditions, like let's say I want to check that the person has a medical record and their address is not null. So we say something like if has medical record p. I'm just going to generate this method quickly so that we have something to work with. So if has a medical record like so, and the person's address is not equal to null, then we proceed with something else even more complicated. For example, we have another function which is called check address, and we check the person's address. We verify that it's not null, so we perform the check on the address, which is once again another method that you would have typically. And then after that, if p dot address dot postcode is not equal to null, that's when you would return, you would maybe set the postcode to p dot address dot postcode. Let's have it as postcode dot toString, maybe, if it's not a string originally. Otherwise, in the else condition, you would say postcode equals unknown. So as you can see, we've gone outside the realm of the maybe monad, because all the maybe monad really does is it checks for null. It checks for the presence or absence of an object, and I've messed things up here. I've added quite a bit more information, and so we would need to construct some different kind of APIs for processing that. But luckily we can do exactly that using the kind of stuff that we used to do for the maybe monad in C#5 days, and that is to build lots of extension methods. So I'm going to build a class called maybe. Now, whenever we have a check for presence or absence of something, I'm going to call it with. And it's actually an extension method, so we would write something like public static t_result with, and the template arguments here are t_input and t_result. These are the generic arguments. Then we have t_input, which is an object, t_input like so. And in addition, we have an accessor function. So we have a function which takes this object, t_input, and returns t_result. That is our evaluator function. And we have a couple of constraints. So we say that t_result has to be a class, and we also specify that t_input has to be a class as well, because both of these have to be nullable, and for that they need to be classes. They cannot be value types. So if the current context of the whole evaluation chain that we have is already null, then we return null. Otherwise, we return the evaluator function on the object. So what we're doing here is we're really doing a continuation passing style kind of interface, but we're doing it with extension methods. So now if your object is null, then nothing is going to happen, and the entire chain of calls is not going to happen. Otherwise, you call the evaluator, and the evaluator just gives you the next element of the chain. So what this means is that instead of writing all of this, which I'm going to comment out, of course, we can do something different. For example, in terms of checking for null, you could have checked, you could have written something like string postcode equals person dot where, or with rather, with x goes to x dot address with x goes to x dot postcode. So this would be a safe way of accessing each of the inner elements, and so we kind of internalized the idea of drilling down with this new with operator that I've built. But remember, it's not all about null, it's not all about presence or absence. So null is part of the maybe monad, but we can do other things in addition to just drill down into an object. And here, for example, we have a bunch of ifs. So we can add additional operators to our demo to support all of this. So the operators that I want to add, for example, let's add the if operator. So in this case, we'll have public static t_input, because nothing changes here, so it's called if. There's only one t_input generic argument, so we have this t_input object that we're trying something on. Then we have a function which returns a boolean, so that's func t_input bool. I'll call it once again evaluator, and that is pretty much all that we need. Once again, we put the constraint that t_input is a class, and here if the current context is null, so if the object being passed in is null, or the chain of objects, we simply return null. Otherwise we perform a check. So if the evaluator gives us a true, if evaluator on the object gives us a true, then we return null. Otherwise, well, actually it's the other way around. We return the object, otherwise we return null. So what does this give us? Well, this means that now in between the with calls where we perform the implicit check for null, we can also add if calls. So this chain that we're building here is becoming a bit more interesting, because now we would have something like postcode equals, so we take P and then we put an if in here. We don't even have to check P for null because that's done implicitly. If has medical record. So the first part of the chain, after we got the P null check, which is built automatically into the if, we have the check for P having a medical record, and then after we checked it, we can do another with, and we can check that the person also has an address, and from then on we're working with the address. Now let's suppose we want to check the address. This is just a call. It's not conditional or anything. It's not an if. It's just a call to something. And for that, we can build yet another operator called do. So do doesn't change the context. It simply invokes whatever you tell it to invoke. So public static t_input do t_input this t_input object and an action. So this time it's an action, not a func. An action on T input called action. Once again, we put the constraint in where T input is a class. Okay, so what's happening here is if the object is null, so if the context is null, we simply return null. We keep propagating the null onwards. Otherwise, we call the action on the object and we return the object. So it's still a fluent interface. This entire thing is a fluent interface. And as a result, the next action that we can do is we can specify the x, and we can check address of that x, which reduces to just check address. So once again, I can get rid of this and just say check address, like so. Okay, so that's the next part. And then of course we want to return something. Now we have this fallback value of unknown. So let's define our last and final operator, which is going to be called result. So result will return the result of an evaluation provided we are not in a null state, and it will return some default value if we are in a null state. So public static t result return. Let me get this back, return. So we have t input, we have t result. This is the object that we're going to call this on, O. We have the function for evaluation, so func, which takes a t input and returns a t result, called evaluator. And we also have the failure value, which is a t result. So if we fail, if the context is null, we have a failure value to work with. Once again, let's put the constraint here where t input is a class. Remember, t result doesn't have to be a class, it can be value type. And what we do here is the same as what we've done before. We check for null and we either return the actual value or the failure value. So if the object is null, we simply return the failure value. Otherwise, we return the result of the evaluation, so evaluator called on O. Okay, so scrolling down here, our final call here would be return, and here what we would do is we would access the postcode. So we would say x go to x.postcode, or if there is no postcode, just put in unknown. Okay, so what we've just done is we've redefined, we've rewritten all of this in terms of this nice concise invocation chain. And in terms of the benefits, we have embedded the maybe monad by virtue of checking for null. So anytime you, for example, access an address, that checks for null, and if it's null, then subsequent calls do not happen. Nothing happens with these lambdas. Nobody calls these lambdas if your current context is null. But if it's not null, then you get towards the very end and you either get the postcode or you get the value unknown. Now, the last thing I wanted to mention is that even though here I'm playing with this idea of reference types and reference types being nullable, you can extend this model to support value types. So for example, if you wanted to have a with that supported value types, you could define something like the following. So you could have public static t result with value, like so, and you would say t input and t result. So you would take t input O as well as a func, which takes t input and returns t result, which is once again the evaluator. So evaluator, but this time you would constrain it differently. You would say where t input is in fact a struct, and this way you get the same behavior without the check for null. So you simply return the evaluator of on the object, so to speak. So essentially, even though the built-in idea of this maybe monad is still the persistent check for null, you could have something different. Like, for example, if you're working with value types, you could check for -1 or 0 and stop the evaluation of the entire chain as soon as you've encountered a particular value. And this is how you go beyond the simple maybe monad.